Okay guys, how are you? So in this video we are going to study formula mass. Okay, we're going to study formula mass. Basically, when I say formula mass, I mean by mass of a formula. Formula I mean by an individual molecule, atom, for example. Okay, here we have, guys, for example, we have sodium. This is an atom. What is the formula? What is the mass of this formula? You will say this is mass of, what is the mass of this formula, of this atom, of sodium atom? I mean by one atom. So the unit of one atom must be very tiny, right? So we use 23 AMU. Okay, this is first example. Second example, here we have H2O. What is the formula mass of this H2O? So H is equal to, it is given, this information is given, Y1 AMU. O, oxygen, is equal to 16 AMU. You don't have to memorize this, but let's calculate it. So I have 2 hydrogen, right? 2 multiplied by 1 plus 16. So the result is equal to 18 AMU. That's why when you hear the word of formula, directly you have to remember the unit of AMU, atomic mass unit. Why? Because the mass of one atom, or the mass of 3 atoms here, atomic mass unit, the unit of mass of atom. Here we have 3 atoms. Okay, so we can say formula mass is any molecule like O2, or formula unit like NaCl, or ion is the sum of the average atomic mass of the average atomic mass of all the atoms, represented in the formula. Or in its formula. Okay, now what I mean by molecule, I mean by O2, for example, H2. What I mean by formula mass, I mean by NaCl. Formula unit, I mean by ionic compound. Or ion, I mean by sodium plus 1. Or the sum of the average, means what? NaCl, for example. Na is equal to 23 AMU. Cl is equal to 35.45 AMU. So the result is equal to 23, formula mass is equal to 23.35.45 AMU. So the result is equal to 58.45 AMU. the result of AMU, it must be written as AMU. That's important. Okay, this is the formula mass. These are given, these information are given, the formula is given also. Just you will do this calculation with AMU. Okay guys, let's talk about mole. The mole represents the basic measuring unit of the quantity of matter according to the International System of the Measurements, SI. So the mole is quantity of what? Of matter. So the mole is quantity of matter, so is equal to the same number of what? Of atoms in 12 gram of carbon. Which type of carbon? Because we have more than one type of carbon. Carbon 12, carbon 13, carbon 14. Okay, so means in 12 gram of carbon, how many atoms are there? For example, we guess that 6.022 means 10 to power 23 atoms, means 6 hexillion particles are there. Okay, like 6 hexillion atoms are there. So 1 mole, how would you say? For example, you say 1 dozen means 12 piece, for example. When you say 1 mole, we mean by what? 6.022 multiplied by 23 particles. So particles, it could be molecules like O2, like H2, so molecule used for those diatomic molecules. It could be atoms like Na, like Fe, like carbon. It could be ions in the solution. Okay, so who did find this fact? Actually, it was this fact before, but no one could find it, could tell us there is such kind of fact in the world as much as clearly like that. The name of this, Avogadro's number. Avogadro's number. Avogadro said, what did he say? He say, in the number of particles in 1 mole of a pure substance, in 1 mole of a pure substance, any type of substance, any substance, pure substance, is equal to how many particles are there? This number particle are there. Okay, particles. For example, you say 1 mole of sodium is equal to 6.022 10 to power 23 atom. 1 mole of O2 is equal to 6.022 10 to power 23 molecule, because the smallest part of sodium is atom, but the smallest unit of oxygen is molecule. That's why we use molecule for this. So this is called Avogadro's number, named in honor of the Italian chemist Amadeo Avogadro, who presented an explanation of the relationship between mass and number of atoms. Okay. The molar mass. Molar mass means what? Mass of 1 mole. For example, mass of 1 mole. You say, what is the mass of 1 mole of sodium is equal to 23 gram. 1 mole of carbon is equal to 12 gram. 1 mole means how many particles, guys? 6O2 10 to power 23 atom. 6O2 multiplied by 10 to power 23 atom. But so the number of particles are same, but their gram are different. Why? Because their atoms are different. Yeah, they have the same number of atoms, like 6 students of 12th grade okay, 1 2 3 4 5 6 student of 12th grade, and compare with 6 students or 6 kids of kindergarten. Okay, 6 students of kindergarten. This is like, for example, this is like hydrogen or lithium, but this is like carbon. Okay, their number are 6. Their number are 6, but their mass are different. Their mass are different. For example, here 12 gram, but here 12 gram, but lithium 3 gram. Okay, they are all 3 gram. Their number are same, but their mass are different. Why? Because each of them greater than one of them. Each of them greater than one of them. Their mass are different, but their number are same. Okay, so the atom of carbon is smaller than the atom of sodium, for example. Okay, I hope you got it. Okay, so let's solve a question here. If you have 200 mole of helium, how many gram are there? So you will multiply by a conversion factor. You say what? 1 mole of helium, this is given, guys, 4 gram of helium. So mole and mole cancelled. 2 multiplied by 4 is equal to 8. Okay, so you say 800 gram of helium. This part is given. Okay guys, look at this question. I'm gonna use mole, make a relationship between mole and mass. What is the mass? So what, if any word come after the what, means this is unknown. So mass of what? Copper is unknown, okay, of 3.50 mole. So mole is given, 3.50 mole of copper. Okay, let's find this. But more information must be given. Here, one information is given. Molar mass of copper is equal to 63 gram per mole. Okay, let's solve the question. Solve I mean by solution. Okay, so you have a rule which is given, right? Which one is given? Mole is given, so you write mole of copper given and make a conversion factor between these information, these given. So mole is given, so you will write 1 mole here and gram here of copper. So guys, you say how many mole? 3.50 mole multiplied by 1 mole nominator, which is 63 gram. So this number multiplies 63 by 55. Okay, 63 by 55 gram. So the result is equal to 222 gram of copper. Okay, here using Avogadro's number. Okay, the question is that how many moles? So here mole is unknown, number of moles unknown. In silver are in 3.01 multiplied by 10 to the power 23 atoms. So number of atom is given. Okay, so mole is unknown, number of atom is given, is equal to 3.01 10 to the power 23 atom. Good. So the result is like that. You say number of atom, which is given, right? Which is given. Always you write the given 3.01 multiplied by 10 to the power 23 atom multiplied by what? You say 1 mole. Always you say 1 mole is equal to 6022 10 to the power 23 atom. In this case you will use this conversion factor. You have to know this, you have to know this, and you will use here. Why? Because number of atom is given, number of atom and number of atom are gone. So 3.0.1 divided by this number is equal to 0.5. 23 and 23 cancelled out to 0.5 mole of Ag. Okay guys, if you look at this question, is a little bit different. Why? Because the mass is unknown. Okay, the mass is unknown in gram, the mass, but the given is atom, number of atom. So there is no any relationship directly between mass and atom. So first of all, you have to, for this type of question, this type of cases, you have to change these atoms to mole. Okay, First step, you will change number of atom to what? To what? To number of mole. Second, you will change the mole into what? The mole into mass in gram. Mass in gram. Okay, let's do this together. Let's do this together. Okay, first, how many atoms are given? 1.2 multiplied by 10 to power 8 atom. How can you change it to mole? By a conversion factor between mole and number of atom. Always we say 1 mole over 6022 multiplied by 10 to power 23 atoms. So 10 to power 23 cancelled with 10 to power 28, 10 to power 8. Why? How did you do this? You will do like that. You say 1.2 divided by 602. Okay, you have 10 to power 8, you have 10 to power 23, so you will just upside down, you'll just raise it to denominator. You say 1.2 divided by 602 multiplied by 10 to power 8 minus 23. So the result, it will be okay, 1.2 divided by 6.02 is equal to 0.99, and this number, when you 8 subtracted with 23 is equal to 10 to power minus 15. Okay, then we have what? Now I have number of mole of what? Of copper. Okay, first step has gone. Let's do change mole to mass. Now you will have this number 0. You have this number 0.199 10 to power minus 15 mole multiplied by its smaller mass. Okay, 1 mole of copper is equal to 63.55 gram. Mole and mole cancelled. Okay, this number multiplied by 63.55, the result is equal to 12.6 multiplied by 10 to power minus 15. This is our result. Just you'll change a little bit. We have two number here before decimal point. You'll leave this decimal 1.2. This is rounding to 7 multiplied by 10 to power minus 14. You will drop one number because you had come to left part, and then the answer is what? The gram of mass of copper. Okay, let's find molar mass. For example, look at this question. What is the molar mass of barium nitrate. Barium nitrate. So barium, molar mass of barium is equal to 137.33 gram. N is equal to 14 gram per mole. O is equal to 16 gram per mole. Okay, good. Let's find this. You say barium nitrate. Okay, so you have 137.33 plus you have 1 nitrogen, right? No, you have 2 nitrogen, so you have 28 plus you have 3 oxygen, no, 6 oxygen, so 6 multiplied by what? 6 multiplied by 16. Okay, 6 multiplied by 16 is equal to 96. So result is equal to 261.35 what? Molar mass, gram per mole. This is molar mass or only barium. This is for only nitrogen. This is for oxygen. They are given in the exam, so just you will find these grams according to the formula. That's great. Thank you very much.